Coding agents are already pretty good at reading repositories, but as the code base gets larger, a new layer has started appearing between coding harness and the source code, that is code graphs. And recently the domain got its three knights solving this from slightly different directions: Graphify, GrapeRoot, and Code Review Graph. All three build some representation of your repository, so Claude Code, Codex, Cursor, or another coding harness does not have to rediscover everything from raw files every time. Where Graphify is heavily focused on understanding and traversing the architecture, but they are not really optimizing for the same workflow. GrapeRoot is focused on deciding which context should reach the model on every turn, and the review graph is heavily focused on what changed, what can break, which tests matter, and how that reaches a PR. So, without any extra code intelligence layer, the harness normally starts exploring, searches file names, open imports, follows function calls, and slowly builds enough context inside the current session to answer your prompt. That works, but the problem is that repository exploration itself now has become a part of the token budget and part of the latency as well. Also, every time you start a new session with some other agent, the exploration becomes a recurring process. So, all three of these tools move some of that discovery work before the model needs it by building a representation of the code base. Let's start with Graphify, as it is probably the easiest one to understand if your goal is onboarding or architectural exploration. It parses the repository locally with treesetter and turns functions, classes, imports, and calls into a knowledge graph. Then it gives you three artifacts: graph.html, graphreport.md, and graph.json. The HTML file gives a visual representation of the repository, the Markdown file gives the higher level architectural view, and the JSON file gives the full graph so you or your agent can query it without rereading the files. To install Graphify locally, you can directly run this command, and this will install Graphify on your local machine. Now to register Graphify globally, you can run Graphify install, but to keep it project scoped, you can run this command. I'll be using the Codex one as I'm using Codex for my harness. By default, Graphify sets up Claude as your harness. So if you are using Claude, you can directly run this command. I'll run this inside my project. So it has done the initial setup. Now let's run Codex. And here I can directly write Graphify. Okay. So it has created the knowledge graph along with all of the three artifact files. So if we open cursor, Graphify out, here is our HTML file, our Markdown file, and our JSON file. So if we open HTML, we can see the entire graph of our code base. Now, once the graph exists in your code base, you can directly run commands like Graphify query, path, and explain inside your project. Graphify answers are graph paths. So instead of only telling the model that two files look semantically similar, it can traverse actual structural edges, just like this. Apart from that, Graphify can also connect documentations, PDF, images, and other non-code information into the graph, which makes it especially interesting when the architecture of the project is spread across code and documentation. Now let's see how Graphify works. So Graphify ingests both code and non-code information to build a knowledge graph representing a code base. Then it divides into two processes. Tree sitter structural extraction uses tree sitter to perform structural extraction of code, in which it simultaneously reads files, directories, and code flow and actively generates nodes and edges from the analyzed information. In parallel, it also reads the documentations, PDFs, and other non-code metadata, maps, and enriches the relationship between code base and non-code base information. Then it structures all extracted information into a knowledge graph, giving you the three artifact files. Also, MCP queries are generated so that your harness can directly query the knowledge graph rather than rereading the entire repository repeatedly. So, if I join an unfamiliar repository and my first questions are what are the main subsystems, what talks to what, where are the central shared modules, how does this service connect to the database and the documentation, then Graphify is the one I would start with. GrapeRoot starts from almost the same repository exploration problem, but its architecture makes a different decision. So their architecture uses something they called pre-injection. So instead of waiting for your harness to ask the graph which files to read or update, GrapeRoot tries to determine the relevant context first and injects compact context directly into the model's request. Now, underneath that, GrapeRoot maintains two useful layers. The first one is a code map, which stores files, functions, classes, imports, and call relationships. The second one is the session memory, which stores which files were read, which files were edited, and what was relevant in earlier turns. So, on the first turn, GrapeRoot retrieves from the code graph, and on later turns, if we keep working on the same feature, it can prioritize the files that the agent already touched rather than rediscovering the same area again. Now, to run it locally, you can directly run this command in your terminal. Okay, so GrapeRoot is installed in our machine. Now, to run it inside a project, you can directly type DG, and if you are using Claude code you'll have to write DGC, and this will automatically load up codecs with our GrapeRoot. So now let's see how it works internally. So initially, GrapeRoot will create a code map of your repository and save it inside the context packer. Then as you keep using it with your agent, it starts to store the files that your agent is reading and updating. So let's say if you are working in an auth feature and in that particular session, your agent is continuously reading and updating files related to your auth flow. So all the files that your agent touched in that session will be stored as a session memory. Now, when you open up a new session with your harness and prompt it again to make changes in the auth flow again, GrapeRoot will be able to provide your agent with the relevant files of the auth feature as it was previously stored in the session memory without the need of reading the entire code graph again. And I think that is what makes GrapeRoot distinctive from the other two tools, as it keeps an active track of files that are being read and updated. So if I already understand the repository and I'm doing a long coding session where I keep asking follow-up questions and editing the same feature, GrapeRoot is more interesting architecture as it decides what context the model should receive even before the model starts exploring. Now, Code Review Graph overlap with both of these tools because it also parses the repository with tree sitter and creates a local structural graph. But the project is much more opinionated around code review and change impact. So the installation is pretty simple. In the terminal, you can directly install it by writing UV tool install code review graph, and you can initialize it inside your project running code review graph build command. The review graph exposes MCP tools for things like minimal context, callers and callees, and review context, and especially impact radius. So let's say if I change the authenticate function inside our auth flow, review graph can walk outward from that chain and ask who calls this, which services depend on it, which test cover those paths, and which execution flows contains this function. And that becomes the blast radius. It also checks for incremental updates. Review graph has a GitHub action that can run the same graph based analysis as we discussed in Graphify and GrapeRoot on a PR. So it can collect post risk information, affected flows, and test gaps, and optionally turn risk into a merge gate. The graph is not only here to help the agent write the change, it can become a part of the review pipeline after the agent has written it. So if my main question is I already have a diff, what did I affect? Which tests should I run? What is the risk of this PR? Then code review graph is the cleaner fit. Now, this is how basically I would separate all of the three tools. So, Graphify asks what is the architecture and how are these things connected. GrapeRoot asks what is the smallest useful context I would give the agent on this turn based on the repo and the session so far. Code review graph asks given this code or this div, what else is structurally affected and what should be reviewed. So all three overlap because all three need a structural understanding of the repository, but they place that graph at different points in the agent workflow. Now, the capabilities at which all of these three overlap are local code graph, structural relationships, and architecture visualization. So now the question arises, could you run them together? Well, technically, yes, because they are not identical layers. For example, I could use Graphify when I first joined the repository to understand the system, GrapeRoot during the actual long running code sessions, and code review graph before I merge the result change. But I would not immediately install all three in every project that I'm working on, as there is a operational overlap, additional hooks, and additional instructions being given to the harness. So the sensible approach is to start with the bottleneck you actually have. If the problem is understanding, start with Graphify. If the problem is context cost across turns, start with GrapeRoot. If the problem is change, risk, and review, start with code review graph. Then add another layer only if the second problem actually appears.